Hey everybody, this is Mr. Piercy. What we're going to be taking a look at in this lesson is how to find the volume of prisms and cylinders. Now, if you have been working with surface area, then you understand how complicated surface area can get depending on the number of bases that you have to keep track of, whether it's the base of the prism or the base of a polygon, the height of the prism, the height of the polygon, etc. Well, with volume, surface area is generally considered to be much more challenging than volume is. If you've been struggling with surface area, then you should get a little bit of a break with volume. If you haven't been struggling with surface area, then volume will certainly pose no challenge. Volume generally is considered the amount of space that something occupies. In geometry, or when we actually refer to the volume of something, whatever it is, we always use whatever the unit of measurement is as that unit of measurement cubed. So centimeters cubed, inches cubed. And the algebra explanation behind it would be because when we say the volume of something, we're multiplying three dimensions together. So inches times inches times inches in the example that I have. Anything multiplied by itself three times would be inches cubed in this case. More of a geometry explanation about why we cube our dimensions is because we're working in three dimensions now instead of two dimensions like we did with area. So how do we actually find some volumes here? Well, first we're going to take a look at some general information. The volume of a cube, because all the dimensions are the same, is if we're going to say length, width, and height for the volume of a cube, or for the volume of something, well, if all of those things are the same, then we can just say whatever that is cubed. So that's where we get the volume of a cube is just whatever the length of the side is cubed. Here, if polyhedron are congruent, then they have to have the same volume, which makes sense. Volume addition postulate that says that if I have a composite shape, I either add or subtract volumes together. So for the image on the left, we would take the triangular prism and add it to the rectangular prism. For the one on the right, we would take the cube and subtract the cone that's been removed from it. The volume of a prism is going to be the area of the base multiplied by the height of the prism itself. Keep in mind that base does not mean it has to be at the bottom, so the image on the left is just there to remind you that base doesn't have to be at the bottom, and the height of the prism is the perpendicular distance between the bases, and volume of a cylinder is pi r squared times h. Since the base of a cylinder is a circle, pi r squared for area of a circle. So how do we find the volume of something? Well, we have two examples here. We have a triangular prism and we have a cylinder. Now, again, with prisms, there is a bit of a challenge with making sure that you identify what the base is correctly and therefore use the correct equation for the area of the base, whether it's a triangle, rectangle, trapezoid, regular polygon. Those are going to be the most commonly used shapes that we use in geometry for prisms, but so you still have to be able to make sure that you identify the base correctly, use a correct formula, and get the area of that shape correctly. But generally speaking, it's not too challenging. So here, the area of the base is, in this case, the base is this whoa, that was a little bit bigger than I expected it to be. The area of the base is, this triangle here and this triangle here. Those are the bases that we're looking at. So the area, in this case, the way that I would set this problem up here, looking at it like at this point, the volume of the base times the height. Well, here I would substitute the area of the triangle, which would be 1/2 times the base of the triangle times the height of the triangle times the height of the prism. Okay, well, what is the base and the height of the triangle? Well, we have a 3 and we have a 1 because it's a right triangle, we don't have to really try to figure out what the height is. The base and the height, let me pick a color here, the base and the height are the two legs of the right triangle. So we can just use those and say the area of the triangular base of the prism is 3.5 or 1.5, or not 3.5, but 3 over 2 or 1.5. So the volume of the base, or the volume of the prism, is going to be the area of the base multiplied by the height of the prism, which in this case is 2. Now, the reason why we left it kind of as a fraction is so that way you can see this 2 in the denominator and this 2 in the numerator. They don't cancel. Shame on your algebra teachers if they do say that. They simplify to be the number 1. So 1 times 3 leaves me with a volume of 3 feet cubed in this case. So moving on to the cylinder. The cylinder has a radius of 5 and a height of 6. So substituting those into that equation, pi r squared times the height, gives us 25 times 6, or 150 pi. So the 150 pi meters cubed, that would be the exact answer. And of course, the approximate answer is the 471.2 meters cubed. So here is an example where we're going to be using the volume equations of something, in this case a cylinder, and we're going to work backwards in order to be able to not find the volume, but find some other dimension of the shape. In this case, we're looking, what is the radius of the cylinder given the volume? So starting out with the volume is equal to base times height, we say pi r squared. In this case, well, the radius in this case is x, so that's why we say pi times x squared, and the height is 10. Simplifying here, at this point, they're giving us an additional step that I don't think is really necessary, but some people may need to see it. Here, they're just kind of moving the 10 in front of the pi, so they're saying 10 pi x squared. And I don't really think that that's necessary. The 10 and the pi, as long as you recognize they're multiplied to your variable, all you have to do is just divide by both of those. So what we do is we divide the 1253 by 10 pi. Now on your calculator, make sure if you say 1253 divided by 10 pi, you put 10 pi in parentheses. Otherwise, the calculator will interpret your keystrokes as saying 1253 divided by 10, and then that quotient is multiplied by pi. So make sure you put 10 pi in parentheses on your calculator, and that gives us an approximate value of 39.9. Then I take the square root of that to find the value of the radius, which would be about 6.315 centimeters. And I didn't fill this one in. Oh, I did fill that one in. So divide each side by 10 pi. So that's how we're, again, just using basic algebra skills to move things across an equal sign to solve for a variable again. So this next thing that we're talking about is something called Cavalieri's principle. It's really kind of, self-evident if you think about it. But if I have two solids and they have the same cross-sectional area, then they should have the same volume. So the example that they're giving us here is, or the example that I'm giving you rather, let's take a look at this one here on the top left. Here I have two rectangular prisms where one is a right up prism and one is an oblique prism, but then I have more of a cylindrical shape. Well, as long as they have the same cross-sectional area and the same height, then their volumes will be the same. We won't look at stuff like that too much where they have different shapes with the same volume, but it'll be typically more like an oblique shape. So you see we have a stack of coins representing a cylinder on the bottom left. Well, if I take that same stack of coins and I make it to where it's not, perpendicular anymore, the volume doesn't change because it's still the same amount of volume that made up the original cylinder. Same thing with the stack of CDs. So as long as something has, so what we will generally use for Cavalieri's principle is just making sure that we understand that the height of an oblique cylinder or an oblique prism is not a diagonal measurement. It's going to be the perpendicular distance between the bases still. So keep that in mind. So like an example here, obviously the height here, we can look at it like this. We can say that this would be the height, but then I could also say, let me make sure I can find something that'll show up here. Here, this would still be the same height of the prism that's formed by the CD cases. That's all Cavalieri's principle is, just letting you know that whether it's a right cylinder or an oblique cylinder or prism, the volumes will be the same as long as the bases and the heights are still the same. So let's take a look at an example. Here we have an oblique cylinder, and we want to know what is the volume of it. Well, it's still a cylinder, so we still use the same equation that says volume is equal to pi r squared times h. Substituting our values into it, we say the radius is 5, the height is 8. Simplifying here would give me an exact value of 200 pi inches cubed, and the approximate value would be about 628. And that's it. It's just you have to recognize that the height still has to be a perpendicular distance. Oftentimes what you might be given is uh, you might be given some slant height like that, and then you would have to use the Pythagorean theorem in some fashion, or trigonometry, or special right triangle rules in order to figure out what the height of the figure would be. Now here we're going to take a look at a composite shape where we're going to either add or subtract volumes together. So in this case we have a big cylinder where we're removing a smaller cylinder. Now you can actually find the volume of the individual shapes and simply subtract one from the other, or you can subtract the area of the bases from one another and then just multiply that by the height, because mathematically it's just the same, because we can find the volumes or find the areas, but they're going to work out to be the same thing. With the, I don't feel like I'm really explaining this too well, so let me just write this out. Here, a volume is going to be pi r squared times the height minus pi r squared times the height for the shape that we have. Well, algebra says that I can factor out common terms, so I can say pi r squared, whatever those things happen to be, I can subtract those, or rather, let me back up here. Because the radius are going to be different, but the height is going to be the same. Since the height is the same, I can factor out the height and then say the area of one minus the area of the other. And that's kind of how they're setting it up here. We can find the actual volumes and subtract one volume from the other one, or we can say the area of one circle minus the area of the other circle multiplied by the height. Sorry if I know I didn't explain that as well as I probably could have, but hopefully I didn't confuse you too much. But if you have any questions, by all means let me know. So here, substituting the values for the radii, we have a radius of 3 for the bigger circle, a radius of 1 for the smaller circle. So the overall areas of one circle minus the other for the bases is 8 pi. Well, if 8 pi is the overall area of the base, that's that difference right here. This is where the 8 pi is kind of showing up. I'm still going to multiply that to the height of the cylinder, which is 7 millimeters. So that works out to be overall 56 pi millimeters cubed as the exact volume, or about 176 for the approximate volume. So now we've come to the end of the lesson. The last several questions are yours to work out. I have it broken up into two sections here. So let's take a look at the first two. Go ahead and pause the video and work out problems 1 and 2 on your own. And when you have your answers, go ahead and hit play so you can check your work with mine. All right, hopefully we have our answers here. The first two are very straightforward. We just want to know what are the volumes of the, oh, hello, email from Willbooks, go away. Here we are just finding the volume. These are very straightforward. There's really not much going on. Now, because this is a rectangular prism, rectangular prisms always, every set of rectangles, the opposite pairs will always satisfy the condition of what the base is. So the base of a rectangle is, or the base of a rectangular prism can be any pair. I chose the two on the left and the right as the base, so I got a volume of 220 meters cubed in this case. So for the next one, we're looking for the volume of the right cylinder. Substituting the values here gives me an exact volume of 324 pi, or about 1017.9. So at this point here, go ahead and work out the last three. The third one, just work the equation backwards to find the value of x. Then use Cavalieri's principle to find the volume of the oblique cylinder, and then find the volume of the composite solid. So go ahead and pause the video and work those out. And when you're done, hit play again. All right, guys, so hopefully we have our good answers here. Working this one out, number 3, where you have a volume of a cylinder, so I'm going to say pi r cubed times h. We're given the volume to be 200 pi, so substitute those values. The radius in this case is half of x, so I'm saying 0.5x. And of course, we have to square that. So on the right side of the equation, 0.5 squared is 0.25. 0.25 times 8 is 2, and x squared is x squared. So that's how I'm getting 2 pi x squared on the right side of the equal sign. At this point, I'm going to divide both sides by 2 pi, which 200 pi divided by 2 pi is 100. And then I take the square root of both sides, and in this case, the value of the cylinder, the value of x in this case is x, or I'm sorry, 10. The volume of the oblique cylinder, here we had to use rules of special right triangles to find the height. We're looking at it here, we're saying this slant height here is 18, so the short leg has to be 9. So 9 radical 3 has to be the overall height of the cylinder, and that's where the 9 radical 3 is coming from. So the exact value of the volume is 324 radical 3 times pi millimeters cubed, or about 1763. And finally, the volume of the composite shape. Here we have a cube plus half of a cylinder, so the volume of a cube is side cubed. The cylinder is half of pi r squared times h. So substituting those values for the side, the radius, and the height of the figure, the height of the cylinder, we get 64 plus 8 pi inches cubed for the exact volume, or about 89.1 for the approximate volume. But that's going to take care of volume. Keep in mind when we're looking at prisms, the base obviously can still change. It can be a variety of different polygons, but really don't have too much else to add here as far as wrapping up or closure. But if you have any questions about anything, ladies and gentlemen, by all means, let me know. You know how to get in touch with me. But until next time, take care and be good.